So, in this lesson, we're going to be trying to understand the notation for integration, which can often be one of the things that trips people up because it can be a little confusing if you're not got used to it, but after a while, you just kind of get used to it and read it as second nature. But is it the first time you're seeing it? I'll try to explain it as best I can. So, carrying on our example, how do we express distance equal to speed, which is a function of time, times time? So we can use our new chunk by chunk method, which is integration, so that speed and time don't just take on one value. Okay, so we're not doing that kind of rectangular multiplication. Well, what we do is we write it out like this. So you'd say distance is equal to the integral of speed, which is a function of time with respect to time. Okay, and that obviously sounds like a massive mouthful, but it kind of makes sense a little bit once you get used to it. So the first part, the integral sign, that means that we are going to be multiplying chunk by chunk. Okay, so this means I'm going to be doing integration. I'm going to be doing multiplication by chunks. Okay, so that's what that means. And then this last bit at the end, this dt bit, means what particular chunk you're considering. So this is called delta t, not d times t. Okay, which is confusing again, but unfortunately it's too late to change how maths is written now. So each dt, so this purple chunk's a dt, this red chunk's dt, that blue chunk even. Okay, so that's just it's the width of each chunk. Okay, and dt width is always the same, right? But it just means what chunk you're interested in. I'll explain it a little bit more as we go forward, but yeah. And then your t represents the position of dt. Okay, so if t spans from 3 to 4, your time that you're interested, your t that you're interested in is 3. Okay, so for this chunk, the t that you put in here is 3, and you'll be talking about this chunk here. Okay, don't hang yourself up about that, but that's what it means. Okay, so where you've got speed of t is equal to 2t, this represents the value we're multiplying by. So at time 3, your speed's going to be equal to 2 times 3, which is equal to 6. Okay? Now, don't worry, okay? Because this can be really confusing. So if you didn't understand that straight away, that is totally normal. It takes a while to get used to these ideas. They're brand new. You've not seen them before. So don't worry about it. So, so just a few things might be easier to understand is where speed of t times dt, it would be much better written if it was like this. If it was speed of t dt times dt, okay? Meaning we are interested in the time at a particular chunk dt. So you can think of that as for chunk dt, so it could be dt1 times dt1, right? So we're interested at the time at this chunk, okay? We're interested in the speed, which is given by the time, times the time that it happened, okay? So don't worry if you don't understand that right away. You might have to watch this a few times, digest it, read some other things, but that is the general idea of all the notation. So reading this question, what's the way to think about it, okay? So you'd think distance is equal to integral of speed times time, right? This is literally it, speed times time, just written out differently. So your distance, your total distance, is equal to your speed multiplied by your time. But what you're doing is you're combining each speed with every time, every little chunk of time at each instant. And you get all these little distances and you add them all together to give your final thing. So just think of integration as multiplication where the components are changing with time, okay? So just think of it as you're multiplying one thing by another, but the other thing changes with time or changes with distance or anything like that. And that is basically the idea. It's just multiplication dressed up a little bit. Okay.